Hello friends, this video on quadrilaterals part 7 is brought to you by examfear.com. No more fear from exam. Now, this was only about the quadrilateral. What should be the angle sum property of other polygons? Because we saw that there could be a polygon with 10 sides. There could be a polygon with 20 sides. So if somebody asks me what should be the sum of the angles for a polygon with say 10 sides, so how do I know that how much it would be? So let us try to see. So let us start with the simplest or the smallest polygon. So which is the simplest polygon possible? That would be a triangle. So a triangle has 3 sides. So for this polygon, what are the sum of the angles? So for this, the sum of the angles is 180 degrees. The next polygon would be the one with 4 sides. So for a polygon with 4 sides, what is the sum of the angles? That is equal to 360 degree, or we can say 2 into 180 degree. Why 2 into 180 degree? Because if we draw a diagonal, the diagonal divides it into 2 triangles. So the angle sum should also be 2 times the angle sum of triangle. That is 2 into 180, which is 360 degree. Now let us consider a polygon with 5 sides. So this is how it would look like. Now here if we have to find out the sum of these angles. Now let's see into how many triangles can we divide this polygon. So polygon with 5 sides is nothing but a pentagon. So let us draw one diagonal. So now we are able to divide it into one triangle, and this is a quadrilateral. So this can be further divided into 2 triangles. So basically we could divide this pentagon into 3 triangles. So in this case, the angle sum should be equal to 3 into 180 degree, which is 540 degree. Now let's go even further. Let's talk about a polygon with 6 sides. So 6 sides would be something like this. So here if we have to find the sum of the internal angles of this hexagon, let's see into how many triangles can we divide this. So with one diagonal, we have one triangle and one pentagon. Now with 2 diagonals, we have 2 triangles and one quadrilateral. And with 3 diagonals, we have total 4 triangles. So basically here the angle sum would be 4 times the angle sum of triangles, which is 4 into 180 degrees, that is 720 degrees. So what do we see? What do we observe from this trend? So from this trend, we observe that a polygon with 3 sides has one triangle, and therefore its angle sum is 180 degree. A polygon with 4 sides has how many triangles? It has 2 triangles. A polygon with 5 sides has 3 triangles. A polygon with 6 sides has 4 triangles, and this would continue. So when you look at a polygon with 7 sides, it would have 5 triangles. A polygon with 8 sides would have 6 triangles, and so on. So basically the trend is that if in case we consider a polygon with n sides, then how many triangles will it have? It will have n minus 2 triangles. That's the trend that it has been following. For triangle, n was 3, so 3 minus 2, 1. For quadrilateral, 4 minus 2, that is 2. For pentagon, it was 5. 5 minus 2, that is 3. So basically for any polygon of n sides, by drawing diagonals, we can get n minus 2 triangles. So that means for any polygon with n sides, we can form n minus 2 triangles. So therefore what would be the angle sum? Therefore the angle sum would be equal to n minus 2 into 180 degrees. Right? So with this formula, we can calculate the angle sum for any polygon. So even if you take a polygon with 30 sides, we should be able to calculate the angle sum for that polygon with 30 sides. So from this we understand, or we derive, that the sum of the interior angles of any polygon with n sides is equal to n minus 2 into 180 degrees. Now this is very, very important. So I hope you understood the logic that how we derived this formula, that why the sum is n minus 2 into 180 degrees. So this is pretty simple. It is just that we did a number of iterations starting from all the polygons, triangle, quadrilateral, pentagon, hexagon, and so on. And that's how we derived at this formula. So now, since quite some time we had been talking about the internal angles. So every time we talk about interior angles. Now what happens to the exterior angles? Now, do you understand the difference between interior and exterior? So let's say this is a polygon. So anything that lies inside the polygon would be interior, and anything that lies outside the polygon would be exterior. So therefore these angles are interior angles, but the angles outside, maybe this angle will be an exterior angle. So that's how we define interior and exterior angles. Thank you. Please visit examfear.com for free quality education. You can learn with a simple 4-step learning process wherein you can watch video lessons, you can ask your questions, you can refer notes, and you can take a free online test. We have content for class 6 to 12 on physics, chemistry, mathematics, and biology along with practical videos. So please subscribe to our channel for daily updates. Thank you.